Hey everyone, and welcome to today's lesson on modular arithmetic. This video will go over the basic definitions and the basic rules. So a lot of modular arithmetic depends on something we call the division algorithm. Now, if you aren't sure about this, I have a full-on video about this, so definitely watch that. But a lot of what we're concerned with in modular arithmetic is the remainder here, which basically is what modular arithmetic is all about. But before we get right into it, I also want to show that you can also see this equation in the form of A equals NQ and plus R. This is the same thing. This is just a different way of saying the division algorithm. So again, if you aren't sure about this, watch that video first. And another thing that I just want to remind you of is what it means for, there's the notation here that we say A divides B, or let's say A does not divide B. And all this means is that when A divides B, there is no remainder. So essentially, if you looked at this formula, there would be no remainder. And if A does not divide B, then you would say there is a remainder. So let's get right into it. In simple terms, a modulo, or sometimes for short we say mod, is the remainder of a division. So when you divide two numbers, the modulo of them is the leftover part. And the notation often looks something like this. You'll have a number A, and then you'll say mod M. This is the notation for it, so A mod M, and what this is looking for is the remainder of the division between A and N. So you divide A by N, and then the remainder is the modulo. So I actually find that you can learn about modulos or mods best when you look at real examples. So for instance, let's say 10, we'll say mod 3, right? So really quick, just so that we're clear, what we're saying is we're going to take 10 and divide it by 3, and the remainder that we get is going to be our final answer. So the easiest way to go about this is just to do long division. So you can say 10 divided by 3 using long division, so 10 divided by 3. And then you just do your regular middle school long divisions, and then what you find at the very end here is going to be the remainder, which is also your final answer here. Let's try another example, and before I solve this one, maybe pause the video and see what answer you get. Alright, now that hopefully you tried it, let's see what the answer is. So this one is a little bit tricky because it trips up students a little bit, because what happens is a lot of students will set it up. They'll say, okay, well, I got to divide, 2 by 5. So they set up their long division like this. They say, okay, there you go. But then they see that 5 doesn't go into 2, right? And they get confused. But this is no different. You just, it doesn't go into 2, so you put a 0 down. And again, you follow the same rules of long division. This will give you 2, which means our final answer is remainder 2, so this is equal to 2. Alright, so let's do one more example. This time let's do a negative number. So negative 4 into mod 11, let's say, right? Again, pause the video, see if you can figure this one out, but I'm going to show you guys a really, really simple trick to do it anyway. Okay, so hopefully you gave it a try, but I want to show you this simple trick. So all you have to do is you have to take the number and add the modulus to it until you get a positive number. So what I mean by that is we'll take negative 4, we'll add 11. Well, what does this give us? This gives us 7, which is already positive, so that's good. And this will be your final answer. So negative 4 mod 11 is just 7. Now, again, just to really point this across, if I had something like negative 13 mod 11, hopefully you can see the pattern here. If I add 11 to negative 13 plus 11, I'll get negative 2. So I need to add it one more time, which will then give me, I can't do math, it'll give me 9, okay? So then this will be your final answer. So that's a simple trick there. Now, something important about modular arithmetic is this idea of congruence. And to put it simply, we say that two numbers are congruent to each other if they have the same remainder in that mod. So the notation for this looks like this. We say that A is congruent to B mod M, right? And so that's what the notation looks like. And all it means is, by the way, is that A mod M, right, is equal to B mod M. Okay? Now, the formal definition that you'll likely get in your textbooks and even sometimes be asked to use to solve some problems on like an exam is this formal definition here. And it just says that let a be and m be in the set of the integers, and let m be greater than 0. Then we say that a is congruent to b mod m if and only if m divides the difference of a and b. Now, again, this might seem super complicated, but remember that all this is saying is that they have the same remainder, right? Okay, so keep it simple for yourself. So again, let's do a couple examples so that you can see. Now I have put the formal definition in the corner here so that we can refer to it, because a lot of the times on your exams you'll be asked to use it. So here's how to use the formal definition as well to solve some problems. Now let's play a little game of true or false. So we'll say that a check mark is true and a cross in red is false. I want you to try to figure out whether these numbers are congruent to each other or not. So the first example is 26 congruent to 2 mod 6, right? So what I want you to try and figure out is pause the video, right? Either use the formal definition here or use the simple definition to figure out if this is true or not, okay? Now that hopefully you've tried it, hopefully the answer you got is true. Now for this first one, I'll solve it both ways, but after this first one, I'm only going to use the formal definition. But let's quickly see. So the simple definition is 26 mod 6 must be equal to 2 mod 6. So let's see. Again, the easiest way to do this is just to do long division. So it fits into it 4 times, 24, 2. So the answer here is 2. Right? And now 2 mod 6, is this also 2? Well, let's see. 2 divided by 6 is remainder 2. So the conclusion is that yes, they are in fact equal. Oop, that's not, there you go. So let's also try it with the formal definition now. So the formal definition is the same thing. So I'm actually going to highlight the numbers. So A, you can see A in blue is this number here. B in pink is this number here, and the mod m is here, right? So all I'm going to do is I'm going to set them up this way. So I'm going to say 6, right? 6 divides the difference of a and b. So I'll write them in the color so that it's very obvious here. 26 minus 2. So all you have to do is now do 26 minus 2, which should give you 24, hopefully. And then you have to just see if 6 divides 24. Which in this case, we know 6 divides 24, so that's good. Now let's do another example here, and this time I'll only use the formal definition. So again, determine if this statement is true or false. So -3 is congruent to mod 5. So give it a try, pause the video, and then see if you got the answer correct. So this time I'm only going to use a formal definition, and I'll go a little bit faster. So again, I'm going to say 5 divides the difference of a and b, which is -3 minus 7. This will give me -10. And so does 5 divide -10? Well, yes, indeed it does. So hopefully that's the answer you got. All right, let's do one last example here. So is it true or false that 22 is congruent to 5 mod 4? Okay, so again, pause, try to figure it out. Hopefully you got this answer. So we're going to see 4. Does it divide the difference of 22 minus 5? Well, let's see, 22 minus 5 is 17. And so we should get, no, it does not, since 4 does not divide 17. And now to build a little bit of an intuition of why that formal definition works, I want to introduce to you real math. And by no means, this is not a formal proof of the definition, but it's more so a way to visualize what is exactly happening. So let's get right into what real math. You can see that in our circle, we have a lot of different sections, but I want to focus your attention on these major sections. This is one major section, and then this is another major section, and you can see hopefully these are all the major sections. Now, I want to point out that we have 4 major sections here, so we can think of this wheel as a mod 4 wheel, right? So remember, the number of sections is the number that the mod that we're talking about. I also want to point out that we're not limited to just 3 wheels. We can also have an infinite number of wheels, right? Okay, so with that, we're going to label each of these sections. So we're going to call this section 0. We're going to call this section 1, 2, and 3. Now, what I want to do from here is keep going. So I'm going to count in clockwise to go up. So let's count that way then. So we have 0, 1, 2, 3. So then I want to go to the next section. Notice that I'm not going to go up right away. I'm going to go to the next section and up because I'm always going to the section that's next, right? And since I ran out of sections here, I'm going to go to the next one. So the next number is 4, hopefully, and 5, 6, 7, and so on, right? So now this is what we have. And again, remember that we can keep this going. So this wheel is an infinite wheel. You can have as many wheels. Now, something super interesting about this wheel is if you take a look at any number in a section, right? So in one of our major sections, so let's say I'm going to look at this section, right? What's interesting is if I take a number from this section and look at what it is in mod 4. So let's say I take 7. So if I look at 7 mod 4, right? So the answer that I'm going to get is going to be 3, which notice it's going to be the innermost circle's number, right? And this is true with any section. So if I take a look at, let's say, this section in green, right? If I take a look at, hopefully you see this pattern, by the way. If I take a look at 8 mod 4, I will get 0. If I take a look at 4 mod 4, I will also get 0. And hopefully you can see if we add another wheel, the next number in here would be 12, and 12 mod 4 also gives you 0. So essentially what we can think of this is this inner circle here, right, represents the mod that you get for any number within that section. So in the same way that we just learned what it means to be congruent, it means that any number within each section is congruent to the innermost number. Now notice something interesting about this wheel as well is that we can actually count up or down, right? So basically we said that we went clockwise to count up, but we can also say then we can go counterclockwise to go down, which means we can add and subtract. So to quickly show you what that means is if I want to add 2 to 1, all I have to do is follow my pattern. I have to go 2 up, so I have to go 2, so 1, 2, right? So 1, 2, and I'm now at 3, so I just went 2 up. So I can think of this as 1 plus 2 in our wheel, right? I can also think of, subtraction. So let's say I want to go 3 down from 7, so I have to go 1 down, 2 down, and 3 down, right? And remember that if we want to go up wheel, so let's say I want to add 1 to 3 or 2 to 3, right? I can't go up straight like this. I always have to go to the next wheel, so it's going to be next section and next wheel, so it'll be something like this. This is one step, and then the next step, and then you can see that basically we can count in this wheel, which hopefully you are seeing what I am trying to get at now. Since we can count, now let's go back to the formal definition and see if we can visualize the formal definition. So the formal definition says that A and B, okay, they're congruent. And what we know about congruency in our wheel is that A and B are in the same section, right? Mod M, and mod M is the number of major sections that we have. So we're doing a case with mod 4, so we have 4 major sections. If and only if M divides the difference of A and B. So let's quickly see how this looks visually. So we know that two numbers are congruent if they're in the same section. So for instance, in this section here, what we also know from the formal definition is that they can only be congruent if they are divisible by the mod. So notice something, what that really means is that if we take two numbers and we subtract them, what really needs to happen is we need to end up somehow in this section with the green. And I'll highlight it in green because this is the section with no remainder, right? So this section has no remainders. And why is that? Well, it's because the innermost number is 0, which means that 4 divides all of these numbers. So let's see if that works. Let's just take a look at this example here. And I'll do it in red so you can see the movement. I want to take 7 away from 11. So I'm going to go back 7 steps. And I'll do this a little bit slow so you can see something cool that happens here. So I'm going to go back 1 step, 2 steps, 3 steps, and notice that I have ran out of a wheel, so I need to go to the next section and next wheel. So I'm going to go here, right? So I have now 1, 2, 3, 4, 5, 6, and 7. And interesting enough, I actually did end up in the section of green. Before you just say, okay, well, that could have happened by chance, let's try another 2 random numbers. So let's just say 2 and 6. Okay, so let's try this out here. So I'm going to go back 2 from 6. So I'm going to go back 1 and then 2. And again, I ended up in the green, which means the difference of these numbers is divisible by our mod 4. Now, let's keep it super simple. Why does this happen? What's important to understand is to end up in any section, but in the next wheel. So if I want to be in this section here with section 3, right? But I want to go to the next wheel. So let's say I want to go to 7 or I want to go to 11, right? What effectively is happening is I have to go up 4, right? So a quick way to think about it is to go from this wheel to this wheel here, I need to go up 4, which means that if I take away, right, 7 minus 3, so if I take two numbers from the same section away, so the difference, right, the distance essentially between these two numbers is always going to be 4, which means, or it's either going to be 4, or let's say I jumped 2 sections, right? And then it's going to be 8 because that's just 2 sections, which is 2 times 4, right? So we're always going to get this difference, right? This distance, which is always going to be divisible by 4. And we are not limited to mod 4. We can take a look at these wheels and remember that these wheels go on to infinity, right? You can draw as many wheels as you need. We can say this for any mod. So we can say even for mod n, right? Given that the wheels are divided into n sections, right? So let me just do a quick example. If we say, let's say mod 8, what this looks like is 4 sections and then 8 sections, right? So as long as the sections are n, right? That essentially means it is mod n. So the stuff we just talked about works in any mod. So long as you start from 0, you go to 1, 2, 3, and this doesn't look very good, I know, but you can see the point that I'm trying to make here is that this works with any number. Now, so let's just quickly summarize what we learned. So we learned what a mod is, and we essentially said that a mod is equal to the remainder of a division, right? So that's the first thing that we learned. And then second, we learned what it means to be congruent, for two numbers to be congruent, right? And then lastly, we learned how to visually understand or kind of explain what's happening in those formulas, and hopefully that helped you out. Now, I did hint a little bit at this with the wheel math, but we can actually do arithmetic operations such as addition, subtraction, multiplication with modulos. Now, notice that I didn't say division, right? So I did not say division, and then I'll go a little bit into detail onto why that is in the next video. But yeah, that's what we'll learn next, is how to do these simple operations.